Hello everyone, I am Arun Kumar. In this video we are going to discuss solar energy, solar panels and different methods of cleaning solar panel. Before all of this, let us check how solar energy generation will become the most dependable energy source of future. Accelerated solar PV deployment coupled with deep electrification could deliver 21% of the carbon dioxide emission reductions, nearly 4.9 gigatons annually, by 2050. Global capacity must reach 18 times current levels, or more than 8,000 gigawatts by 2050. Asia would continue to dominate solar PV use, with over 50% of installed capacity, followed by North America, 20%, and Europe, 10%. Solar PV project costs, already below marginal fossil fuel costs in global terms, are set to decline further in the decades ahead. Solar PV is a fast evolving industry, with innovations along the entire value chain driving further, rapid cost reductions. Floating PV is a prime example, with global cumulative installed capacity exceeding 1 gigawatt in 2018 and clear potential for rapid growth. Rooftop solar PV systems have spread rapidly thanks to supporting policies, such as net metering and fiscal incentives. Energy transformation brings socioeconomic benefits. The global solar industry could employ over 18 million people by 2050. So how can we define solar energy? Solar energy is radiant light and heat from the sun that is harnessed using a range of ever-evolving technologies such as solar heating, photovoltaics, solar thermal energy, solar architecture, molten salt power plants and artificial photosynthesis. The large magnitude of solar energy available makes it a highly appealing source of electricity. The United Nations Development Programme in its 2000 World Energy Assessment found that the annual potential of solar energy was 1,575 to 49,837 exajoules. This is several times larger than the total world energy consumption, which was 559.8 exajoules in 2012. Solar power is the conversion of sunlight into electricity, either directly using photovoltaics (PV) or indirectly using concentrated solar power (CSP). CSP systems use lenses or mirrors and tracking systems to focus a large area of sunlight into a small beam. PV converts light into electric current using the photoelectric effect. Solar power is anticipated to become the world's largest source of electricity by 2050, with solar photovoltaics and concentrated solar power contributing 16 and 11% to the global overall consumption, respectively. In 2016, after another year of rapid follows, solar generated 1.3% of global power. Now let us check how to harness the solar energy through modern semiconductor devices such as solar panels. Most solar cells are made of silicon. Silicon has 4 electrons in its outer electron shell. When many silicon atoms come together, they form a crystalline lattice, due to what's known in chemistry as covalent bonds. This would look as follows. If we add a small number of atoms with 5 electrons in their outer shells, like phosphorus. However, there will be some free electrons floating around because they simply don't fit anywhere in the crystal structure. If we add an element with only 3 electrons in its outer shell, like boron, we'll have an awkward electron hole in the structure. Silicon plus an element with 5 outer electrons is called an N-type semiconductor, N for negative. This is because silicon usually has 4 outer electrons. With 5 outer electrons, it has an excess of electrons, making it negative. Silicon plus an element with 3 outer electrons is called P-type semiconductor, P for positive. When we put N and P-type semiconductors next to each other, we form what is called a p-n junction. When a free electron from the N-type half makes it to the P-type half, it fills a hole there. The hole filling happens in a small stripe where the P and N-type halves touch. This is called the depletion region. When sunlight hits the depletion region, it can cause electrons to leave the holes they filled. Electrons moving through a wire. That's a current. And that's how we get electricity using solar PV. Solar panels are placed on open areas to gain maximum irradiance of sun and making it vulnerable to many natural threats: water, humidity, temperature, dust, soil, various sorts of debris, which will reduce to solar panel efficiency and eventually leads to permanent damage to solar panels. The solar photovoltaic panel cleaning technology can considerably increase the efficiency of electricity generated and also increase the durability of solar panels. The various cleaning methods, such as electrostatic cleaning system, superhydrophobic coating methods, mechanical method, microcontroller-based automatic cleaning method, self-cleaning nanodomes. Electrostatic cleaning equipment has been developed to remove dust from the surface of soiled solar panels. When a high AC voltage is applied to the parallel screen electrodes placed on a solar panel, the resultant electrostatic force acts on the particles near the electrodes. The reciprocatory motion of the particles between the electrodes arises due to the alternating electrostatic force, where some particles pass through the openings of the upper screen electrode and fall downward along the inclined panel owing to the gravitational force. Another methods is by coating solar panels with hydrophobic coatings so the dust and water will not stick to this PV panel and natural wind and rain keeps the panel surface dust-free. These coating will last for 2 weeks and their performance will increase based on the cost of material used. Talking about nanodomes, these are much more of energy efficiency based devices. These devices combine many nanophotonic effects to both efficiently reduce reflection and enhance absorption over a broad spectral range. These nanodome devices, when modified with hydrophobic molecules, present a nearly superhydrophobic surface and thus enable self-cleaning solar cells. Mechanical methods is comparatively economic. It includes conventional hand wash and advanced washing gadgets with semi-automatic machines. These require water, cleaning lotion, human labor and much more. Finally, coming to microcontroller-based cleaning mechanism, these are most advanced way of cleaning solar panel and provides us with maximum efficiency and low cost. These include microfiber-based smart solar panel cleaning mechanism. This system consists of microcontroller-based solar panel cleaning system in which ambient sunlight is measured using LDR sensor and panel voltage is compared with it to drive to cleaning motor. With the help of motor driver, LED indicators are provided to show system output. GSM module is connected to send text messages to user or service center about the condition of solar panel. A LCD panel is used to display the current status of system and voltage output of PV module. These are cost-effective, use waterless cleaning methods and can track solar panel power output and better communication system to ensure the proper working of PV modules. Because of these merits, current practices of solar panel cleaning using smart automatic robot cleaners is emerging in the world. Various cleaning machines such as Gecko Solar Robot, Gecko Solar Farm Robot, Boson Robotic Panel Cleaning System, and Automatic Water Sprinkler are some of them. With proper advancement in creating higher efficiency solar panel and better cleaning methods, we can minimize the electricity demand needed in the future. And there are many reasons to confirm that automatic solar panel cleaning robots will be the future of solar panel cleaning. They must have the following advantages. Water-free. It uses microfiber and controlled airflow cleaning system for removing panel soiling. Energy independent. It comes with its own solar panel and battery and does not require any external electricity to run the equipment machine. Ecological. Mostly cleaning equipment itself requires cleaning, maintenance, but with the patented eco-hybrid mechanism in the equipment, self-cleaning mechanisms decrease the need for maintenance. Efficient. Each cleaning fleet can be remotely managed from a computer or a mobile app. Schedule cleaning, real-time data and much more. Built to last. All components passed through rigorous stress tests in high temperatures, over 65 degrees Celsius, and desert conditions to ensure stability over time. All system wiring is of aluminium profiles to protect it from environmental conditions. No side effect. Moving along a rigid frame, the E4 adds no load to the panel surface, and has been proven to be fully safe on both panels and anti-reflective coating arc. The technology developed by the researchers can remove 99% of dust during automated cleaning operations. The technology has been independently tested by world-renowned industry experts PI Berlin, Photovoltaic Institute Berlin. Now we can discuss the future solar power plant goals of our Kerala State Electricity Board (KSEB). Expects to achieve solar power generation to the tune of 1,000 megawatts by 2022. The solar energy program announced by the board has received enthusiastic response. A total of 16,000 KSEB consumers have already registered under various schemes, and the board will be able to provide support to establish 75,000 solar plants with a capacity of 3 kW as of now, said nodal officer for KSEB's solar energy program. A consumer, availing of subsidy, will be able to establish a solar power plant generating 3 kW power by investing around 80,000 rupees. The launch of the domestic rooftop solar plant program is a landmark for the state, which has consistently made a push towards renewable energy options. KSEB has designed the subsidy scheme in such a way that an ordinary domestic consumer would be able to join the renewable energy program by making a small investment. I hope all of you understand the topic and thank you